So I will be studying this particular class. So in the previous class, what we have studied, we have gone with a push operations, pop operation, and the stack implementation using arrays. Okay, so you have gone with two programs. One is using arrays, the other one is using dynamic arrays. Okay, so any doubts in the push and pop operation? So you have any doubts in program in push and pop? Have any doubts? Understood the push and pop operation, right? Okay, so in today's class, we will be going with a lecture 11, that is stack applications. So in the previous class only, I have told you where are the stacks are being used. So first in this contents, we are going with a stack application. The other one is polish notation. The other one is infix to postfix conversion. So these are the three concepts we are going. So where are the stacks are used, and polish notation, and infix to postfix conversion. So come for the first one. So that is, so first one is stack applications. So where all you are getting the stack applications. So first one is very, very important for conversion from one form of expression to another. So expression means any arithmetic expression where you find operator and operand. So operator and operand, then we consider it as an expression. So conversion from one form of expression to another form. So which are the forms of the expression that we will see in the next slide. Okay, so for now you understand. So where you are using the stack, it is used for conversion from one form of the expression to another form. So these are the example. Which are the forms you are having is infix is one form. Next one is postfix. Next you have prefix also. Okay, so that is stack is used in conversion from one form of expression to another form. So second application is to check the parenthesis matching in expression. So stack is used for checking the parenthesis matching in the expression. So third one for memory management. Okay, so next you come for the where they are used in backtracking problems. So backtracking problems means there are some programs where you once you get the output, you backtrack to input level. So some of the examples of backtracking are decimal to another number system. The other one is maze tracer, redo operation, and DFS. So this we will go through when you come into the problem. So next you find reversing the data. Next you get finding palindromes. So next recursive operations. So keep in your mind. So these are the applications of the stack. So in that you will be discussing conversion, checking parenthesis. Next you go with a recursive operation and finding palindromes. Okay, so these two are same. Reversing data as well as finding palindromes are related to each other. Okay, so next you will be having recursive operations. Understood? So in that, keep in your mind. So which are the important one? I will be marking it with star. So first you get the first application is conversion. Second is checking parenthesis. Next you go with reverse. Next finding palindrome. So finally recursive operation. So this all this which are marked with star, that we will be seeing in this particular module. Okay. So they keep in your mind for how many you have to do. 1 to 5. There are 5 things, applications that you have to go through. Keep this one in your mind, the applications of stack. Okay. So remember all star marked applications. Okay, star marked applications you have to remember. Okay, so which are the star marked? One is conversion, the other one is parenthesis matching, next is reverse data, next finding palindromes and recursive operation. Okay, so these are the concepts you are having. So next we go into the detail. So come for the expression. So conversion from one form of the expression to another form. So which are the forms of the expression? First we have to see. Before you convert from one form of the expression to another, you have to know which are the forms of the expression. So forms of the expression are infix, prefix and postfix. Okay. So infix means fix the operator between the operands. So keep in your mind, in means in between. So in between, so fix the operator in between the operands, that we call it as infix. Okay, so next you come for the prefix. So prefix means place the operator before the operands. So suppose infix is a plus b, prefix is plus ab. So this one can be plus ab or plus ba. Okay, so place the operator before. Prefix means pre means before. So you are placing the operator before the operands. So similarly for postfix means placing the operator after the operands. So understand the words? Are you getting the words? Answer me. Are you getting the words infix, postfix and prefix? Only one reply. So infix means, so tell me what is infix? So what is infix? Okay, good. Placing the operator in between the operands. Good. So prefix means placing the operator before the operands. So keep in your mind, a plus b is the infix. Prefix can be plus ab or plus ba. So postfix is ab plus. So this is the operator. Now you come for the next one. So here there is no parenthesis. Okay, so no brackets are there, but you come for the next one. So coming for the next one, now you see you have to evaluate the operate parenthesis first, and then you have to go with the next part. So first, which is the parenthesis part you are having? It is a plus b. So a plus b prefix is plus ab or plus ba. Similarly, when you come for this one, this is considered as one part. So one part means, so one part means C plus D will be evaluated as plus CD. So this one is plus AB star plus CD. So what you will get? It is star plus AB plus CD. So that is star will come first. So what you have inside the brackets, that is to be evaluated first. So what is there inside the brackets? So A plus B is being evaluated first. Next, C plus D is being evaluated next. Then what is the result you are getting? That is it is evaluated with star. So first part is A plus B, prefix is plus AB, C plus D, prefix is plus CD. So then now you add all these things. So star plus AB plus CD. So but they have taken plus DC plus BA. You can take it as it is. So now you come for the postfix. So postfix means operator will be placed after the operands. So what is the postfix expression for this? It is AB plus, this one CD plus. So first you get AB plus, next CD plus, finally star. Okay. So are you understanding right? Are you getting the expressions? Okay, so come for the next one. So here you are having B star B minus 4 star A star C. So no parenthesis is there. At that time, what should be done? So this one you execute first. So B star B you have take it one place. Next 4 star A star C you take it next. So evaluating you will get BB star. So this one you will get 4A star C star. So for A star, C star, and finally you will get minus. So evaluating B star B. So B star B is given as star BB. Okay. So now you evaluate this one. 4 star A is given as star A4. Okay. So star A4. So that will be evaluated with star C. So you will get star C star A4. So finally you add it with minus. So first part is B star B. Next part is 4 star A star C. So evaluating you will be getting it as minus you will get. So star C star A4 star BB. So that will be the prefix expression. Okay. So how you are going to, which part you are taking first? B star B will be taken first. Next you take 4 star A. So 4 star A will result in star A4. So star A4 star C. So you will get star C star A4. So finally you make it with minus. So that will be the prefix. Come for postfix. So postfix means first BB star, next you will get 4A star, C star minus. So BB star minus 4A star, C star minus. So now you come for the words. Prefix is known as a Polish notation and postfix is known as a reverse Polish notation. So keep in your mind, prefix is called as a Polish notation. So next you, after that, postfix you take it as reverse Polish notation. So this is the infix, prefix and postfix. Okay, so now you come for the one of the program. So have you understood this infix, prefix and postfix, right? Understood? So for this, write the prefix and postfix. So I've given the question C plus D star E. So you write the prefix, sorry, it is prefix and postfix. You write the prefix and postfix for that particular example. I've given the simple one. So what will be the prefix and postfix for C plus D star E? Answer. Star E plus DC. Only this much? So what you are having here, first you are having C plus D. So it is C plus D star E. So which one is to be evaluated first? So parenthesis part. So parenthesis part is, so, so it will be, what you will get? So C plus D will be evaluated as what? Plus CD. So with star E, so it will give you star E plus CD. So what you are getting? So it is prefix is star E plus CD, postfix is CD plus E star. Okay, good. So I got you understood. So now you come for prefix is known as Polish notation and postfix is known as reverse Polish notation. Okay, so I hope you understood this particular thing. So now you come for this particular program. Okay, so this one we will be taking it as, so decimal to binary using stack array. Okay, so what are the stack operations? So keep that one in your mind. So we have to give a decimal number and that is to be converted into binary. Okay, so that is one of the problem you have where you come across the stack. So stack will use push and pop operation. So what is the steps for push operation? Steps for push and pop. Tell me. What are the steps for push and pop operation? I've given 3 steps each for push as well as pop. So which are the 3 steps? Give in terms of step 1, step 2 and step 3. Which are the steps? Can anybody can tell? 3 conditions for push and pop. In yesterday class we have gone through. Check for overflow. Second, increment the top. Third, place the item on top position. Okay, so you have told correctly. So for push operation is check for overflow. So that means topmost element is double equals max. So what is the max? It is the topmost element of the stack. So if top double equals max or max minus 1, it is going to check for stack overflow. Next, increment the top. So come for your push operation. You have taken top plus plus. Next, place the item. What is the item? X is the item that is been pushed onto the top of the stack. So similarly, what is the condition for pop? So for pop, okay. So for pop is check for underflow. So underflow means, so if there is no elements, so if there are no elements in the stack, so top is a pointer which contains a value -1. So top is equal to -1 at that time stack underflow. So now you point the element. So stack of top is equal to x. So x is equal to stack, point the element, next make it null and decrement the top. So point the conditions are, first one is stack underflow, second you have point the element, make it null and decrement the top. So these are the three lines, your three conditions for popping the element. Okay, so now you come for the program part. So you have gone with a push operation, you have gone with a pop operation. So now you come for the main. Before you go for conversion, come for main. So what is the conversion? You have to take a decimal number and you have to convert it into binary. So converting a decimal into binary, how you convert? So can anybody can tell how you convert a decimal number to binary? In first year you have learned. So how you convert? How you convert a decimal to binary? So just don't go for anything. Just I will give you a number 10. Okay. So number 5. Okay. So how you convert it into binary? So can anybody know how you convert a decimal number 10 to binary? So for example, you take it 5. Okay. So binary means 1 and 0. Okay. So I will give you a decimal number 5. Okay. So what you do to convert it into binary? So binary value is 101. So how you get this value 101? Okay, divide by 2 and take the remainder. Good. So you have to divide that particular number. What is the number? 5. So that number 5 and divide by 2. So what are the remainders you are getting? You have to take. So that is the condition. So first you have to take a number that I will be taking. Start with a main program. So you start with int of main, int of num. So that number is a decimal number. So printf, enter the integer. Now you're reading the value. So suppose I give a value 5. Okay. So go with a simple one only. So for take 4. So print binary equivalent. So then I call a function dec to bin. So this is the function. So it is the function to convert dec to binary. So this is the function we are going to take to convert a decimal number into binary. So come for here. So this is the calling function. Called function will be there here, dec to bin of int num. Okay. So first you take stack of max. So to for conversion, how many number is? Input is only one number, that is 4. Okay, its binary equivalent will be how many? The binary equivalent will be 3 digit or 4 digit. So binary equivalent of 4 is 0100, or you can simply go with 100 also. So binary equivalent of 4 is, so you are giving how many integer? One number, but output you are getting it as 3 numbers. So that's for that purpose you are going to take it as stack. Okay. So what is stack of max? It is a stack is a location which holds how many elements? 50 elements. So for now you are using 3 elements here. So if num not equal to 0, that means so 4 not equal to 0 condition. So divide the number by 2 and take the mod. So mod means it will take the remainder. So keep in your mind what you are giving, it is going to take the remainder. Okay, so then push stack comma remainder. So suppose if you suppose you divide 4, so 4 mod 2, so 4 mod 2 will give the result as 0. So push stack comma remainder, so stack will contains, so now stack will contain 0. So now divide the number by 2. So divide the number by 2, it will give you what? So it will give the quotient. So quotient is equal to 2. Okay, so that is num is now what, this is the quotient. So that is been placed to num is equal to 2. So again loop will come here. So now 2 not equal to 0. So second condition, 2 not equal to 0. So condition true. Now again remainder. So it will go with the remainder. So what is the number? 2 mod 2. So 2 mod, so 2 mod 2 is what? Remainder is again 0. So push the remainder onto here. So now you divide the number is equal to number by 2. So now number will is equal to what? So 2 by 2 is equal to 1. So now again come for the while loop. So now what is the num? Num is 1. 1 not equal to 0. Condition is true. So 1 mod 2. So 1 can't be removed, modded with 2. So it remains same. So what is the equivalent you are getting? Stack is 1. So now you divide 1 by 2. So 1 by 2 will result in value 0.5. So this will result in 0.5, but here the num is of which data type? So num is of integer data type. So 0.5, it will take it as 0. So now you come for here. So 0 not equal to 0. Condition false. So what is the binary equivalent you are having? It is 0, 0, 1. So that will be printed. Okay. So have you understood this decimal to binary? So I have told with a logic also. So first one will take remainder, move it onto the stack and divide a number by 2. So that is the conversion method you are taking to convert a decimal number to binary. So I have told with the iteration also. Have you understood? Have you understood the logic? So once again, so I'm running out of time, Mr. Shah Mukhtar. So I will tell only the decimal to binary. You go with that. Okay. So first you see what is the number you have taken. You take that one in your mind. So first example I have taken is 4. So 4 binary equivalent is 100 that you have to get. Okay. So while num not equal to 0, what is the num you have taken first? So num is 4. 4 not equal to 0. Condition is true. So now you divide that particular number modded with 2. So mod will give you remainder. So that I will tell 4 modded with 2. What is the remainder? 0. Push it out to the stack. So that is the first 0 what I have placed here. So remainder is been placed onto the stack. So now you divide that number with 2. So what is the number you have? 4. 4 divided by 2. What you will get? So it is 2 value. So now the value of num is 2. So again go for the while loop. So 2 not equal to 0. So condition is true. Again you divide 2 mod 2. What is the remainder of 2 mod 2? You will get the remainder as 0. So remove that 0 to the stack. So that is the second 0 what you are having here. Okay. So now you divide that number with 2. So dividing that number with 2, what you will be getting? You will get it as 1. So again, sorry, it is 1. So again you move here. Num is what? 1. 1 not equal to 0. Condition is True. Again, you divide 1 modded with 2 can't be divided because numerator is greater than denominator. Sorry, lesser than denominator. So you can't divide. So 1 modded with 2 means value is 1. So move it onto the stack. So remainder is 1 only. So now you divide that number with 2. So 1 by 2 will give quotient 0.5. Okay, so but number is of integer data type, so 0.5 is being taken to 0. So now again you come here, 0 not finally you will go with 0 not equal to 0. So 0 not equal to 0, condition false. So at that time you come out of the loop. So when you have no contents, so top not equal to -1, print pop of stack. Okay, so this is the logic for conversion from decimal to binary. So keep in your mind, while converting the decimal to binary, you have to go with taking the remainder, moving the remainder onto stack and dividing the number. So steps I will give you for conversion. So what are the steps you have to go with? So first one is take the number. So second one, so take the remainder. So take the remainder by dividing number with 2. So third step, move the remainder to stack. And finally fourth step, divide the number with 2 and take quotient. So these are the steps you have to go through. So first one is take the number. If number not equal to 0, take the remainder by dividing the num with 2. So third one, move the remainder to the stack. So fourth one, divide the number with 2 and take the quotient and assign it to number. So these are the steps for conversion from decimal to binary. So go for your chart and see this. Understood? Understood? Only one yes? No doubts? Okay. So this is the attendance link. Those who are not filled, you can fill it here. Thank you.